Jonathan Jasper, URK23CS1080. This is my experiment number 3. In this I imported the dataset using the pandas library. Here I used read CSV function to load the wine regression dataset in data frame. Then I displayed the first few rows using it to understand the dataset structure and verify the data loaded successfully. In question 2, I performed data cleaning by checking missing values in the alcohol and quality columns. Then I replaced missing values using the mean of each column. This process is called mean imputation, and it helps improve dataset quality before model training. I selected alcohol as the independent variable X and quality as the variable Y. The independent variable is used for prediction, while the dependent variable is the output we want to estimate. Here I calculated the slope B and intercept B0 using the linear regression formula. These coefficients define the regression equation that represents the relationship between alcohol content and wine content. Then I calculated and predicted quality values using the regression equation. These predicted values represent estimated wine quality based on alcohol percentage. I calculated the sum of squared errors, also called SSE. It measures the difference between actual values and predicted values. Here I calculated the root mean square error, RMSE. The RMSE shows how much prediction error exists in the model. Smaller RMSE indicates better prediction performance. In question number 8, I calculated the R square value. R square measures how well the regression models explains the relationship between alcohol and quality. Higher R square means better model fit. In question number 9, I plotted the regression line along with the actual data points. The scatter plot shows original values and the straight line represents predicted values from the regression model. In question number 10, I predicted wine quality for a new alcohol value of 11.5%. Using the regression equation, the model estimated the expected quality score successfully. In multiple linear regression, I already loaded the dataset. Here I handled missing values in alcohol sulfates and quality columns using mean imputations. In question number 3, I selected alcohol and sulfates as independent variables H1 and H2 and the quality as independent variable Y. Using multiple features improves prediction accuracy compared to single variable regression. In question 4, I calculated regression coefficients using the normal equation method. This method computes intercept B0 and F coefficients B1 and B2 mathematically without iterative training. In question 5, I calculated predicted quality values using regression coefficients and independent variables. Here I calculated the sum of squared errors to measure prediction error. In question 7, I calculated root mean square error to evaluate model performance. And in question 8, I calculated the R square value to check how well the model explains variations in quality. At last, in question 9, I predicted wine quality using alcohol value 12.0 and sulfate value 0.65. The regression equation generated the predictor successfully. Here logistic regression, I performed pre-processing by replacing missing values using mean imputation. This ensures the dataset is clean before applying logistic regression. Here I selected the multiple chemical features as independent variables and wine type as the dependent variable. Logistic regression used here because the output variable is categorical. Here I applied the gradient descent. I implemented gradient descent to reduce cost function error iteratively. The algorithm updates weights step by step to improve prediction accuracy. This function converts output into probability between 0 and 1. I plotted a graph between iteration and cost function. The graph shows cost decreasing gradually, which indicates gradient descent is working correctly. In question number 5, I calculated model accuracy by comparing predicted values with actual values. The accuracy result shows how well the logistic regression classifier performs.